Hi, my name is Charlie Stanier, and I'm a faculty member in chemical and biochemical engineering at the University of Iowa. One of my research areas looks at the intersection or the nexus between air quality, energy use, climate, water, and agriculture. And that's what I wanted to talk about in this video. I have a project with a bunch of collaborators here at the University of Iowa called Decarb 2040. And I'm going to talk about some of the work we're doing within Decarb 2040. In the yellow box on the right are partners from around the state that are helping us with Decarb 2040. And we have a two-day meeting coming up on April 21st and April 22nd called the Hawkeye Decarbonization Summit. And this is the poster for that meeting. Our keynote speaker is Saul Griffith, who's a prominent proponent of electrification. So to take technologies that currently use fuels and to convert them to their electric counterpart. When researchers talk about climate research, they can mean different things. Here, I've shown 4 different classifications of climate research. There's climate science, climate impacts, climate adaptation, and solutions that will limit the amount of climate change we see. I'm mainly talking about the solutions part. Climate science is really important. That's unraveling the connections between different parts of the climate system, like clouds and the ocean and hydrology. Impacts is figuring out how much the changes to the climate system will impact things like food production, economic systems, transportation systems, immigration. Adaptation is changes we can make to the built environment that will limit the negative impacts of climate change, and solutions are things we can do now that would decrease the amount of climate change we're going to see and the associated negative impacts. So one thing that is commonly talked about is decarbonization and reduction of emissions as part of a mitigation challenge. And what I show here in this graph is years from 1970 to 2100. In gray, you see the historical emissions going up each year, global emissions of carbon dioxide and other global warming gases. And to stabilize the climate system, we need a rapid reduction to what's called net zero. And people throw out different years at which we need to achieve that by, like 2040, and that in our title, Decarb 2040 or 2055. And we see this so often that we forget where it comes from. And so who decided 2040 was the year? And then the second question is, what would this look like if we achieved this in Iowa? So decarbonization by around the year 2040 comes from a prominent IPCC report. IPCC stands for the Intergovernmental Panel on Climate Change. This is a large group of volunteer scientists who are well respected, chosen for their credentials, and they work together to summarize important pieces of climate change science every few years. In their 1.5 degree report, they said it would have severe negative consequences if the climate overshoots by 1.5 degrees C or more. And to avoid that, the amount of emissions decrease, we need to come down 45% from 2010 levels by 2030, and we need to reach 0 by 2050. So that's where that comes from, and it's widely adopted in many corporate and country pledges to reduce emissions. The amount of change we need, if you started in 2010, the baseline year for IPCC, you have to reduce at 2.94% per year. for that 20-year period. And that's what this would look like. 2.9% decrease per year for 20 years gives you a 45% decrease. Here's the actual track record in Iowa, and we have a decrease of about 1% per year for the first 12 years of that period. And so if we're going to meet this IPCC goal, we would need to accelerate decarbonation substantially in Iowa. This is that same data, but now I've got two lines, a black line for Iowa and a red line for the US. Iowa's per person emissions are about twice the US emissions. And then I'm showing what the path to net zero would look like for Iowa and for the US. On the right, we have Iowa's greenhouse gases, but now with percentages assigned to the different parts of Iowa's economy that are responsible for those. You might think that electrical power production is the biggest piece, but it's not. The biggest pieces are agriculture and fuel use. So this is the gray box, residential, commercial, industrial fuel. And this is the burning of natural gas and propane to make steam for industry, other heating needs for industry, as well as heating homes, office buildings, schools, things like that. So we have a lot of solutions available, and I've color coded all these solutions. There's about 40 solutions on here. And the gray ones have to do with residential, commercial, industrial fuel use, and the blue ones with transportation, and the peach ones with electricity generation, and green is agriculture. And there's a lot of people working around Iowa to figure out which of these are the best ones to implement, the ones that are going to be the most effective, lowest cost, and easiest for Iowans to implement. And we're getting a bunch of those people together at the Hawkeye Decarbonization Summit to talk about several of these areas of solutions. So we'll have the link for our 2-day meeting in the video.